Welcome to the Deep Dive, your essential shortcut to understanding the accelerating world of artificial intelligence. We're zeroing in on the last couple of weeks, and honestly, it feels less like prediction and more like, well, a violent strategic inflection point. This seems to be the new normal, doesn't it? An accelerating AI arms race, progress measured in weeks, not years.
That pace is just relentless, absolutely. And we're really past discussing potential now. We're analyzing immediate infrastructure, immediate commercial reality. Our mission today really is to synthesize the three major battlegrounds shaping AI's trajectory right now.
Okay, what are those?
We've got to cover the massive leap in technical capability of the models themselves. Then there's the unprecedented infrastructure war fueling all of this. And finally, the new era of global regulation that's really trying to catch up.
Right, and our goal here is to balance those, fascinating technical details, the benchmarks, the specs, with practical value. We want to give you clear, actionable insights into what this all means for your work and for the world. We've got a huge stack of sources here.
Yeah.
Okay, let's unpack this. Starting right at the top with the brain power, these new frontier models. So the single biggest shift we've identified, I think, is AI moving beyond just being a clever chat tool. It's moving into complex, multi-step reasoning, autonomous action. We're talking AI systems that don't just answer your question, but actually manage a whole project. This is what people are calling agentic capability, right?
That definition is absolutely crucial, yes. Agentic AI means an AI that can handle multi-step projects. Things like, running a complete software update, planning a complex business trip with lots of constraints, or even generating an entire scientific paper, all without needing a human prompt at every single step. It sets its own sub-goals and just executes them.
Okay, so who's leading the foundational model race in this new era, this age of autonomy?
Well, Google DeepMind is fighting very aggressively for position with Gemini 3.0 Pro. Now, this model is currently in what our sources are calling a stealth rollout. Basically, they're using phased deployment A/B tests to gather real-world data before any big official launch.
Interesting. And technically, what's it capable of?
Technically, it's proving incredibly versatile. It reportedly achieves human-level performance on some really challenging, complex reasoning tests. That helps at top leaderboards like the ARK AGI-2.
Okay, but when you say versatility, what does that really mean in practice? Is that a genuine competitive edge? Or is it maybe Google trying to fight its rivals across too many fronts at once?
That's a fair question. Versatility here means it's not just solving, say, abstract math problems. It's also excelling at practical outputs, like generating complex SVG graphics. That's a measure of both creative and technical accuracy. So they're claiming a model that's both highly intelligent, and practically skilled.
Right. In OpenAI's response, GPT-5, that seems designed to define what they're calling the unified model era, integrating that advanced reasoning and rapid response all into one seamless system. We've seen some frankly, staggering performance gains reported here.
We really have. The numbers are, well, they're hard to ignore. Reports are showing 144% better coding performance than its predecessor, GPT-4o, and achieving, get this, 94.6% accuracy on expert-level mathematics problems.
Wow. Let's put that 144% figure in context, especially for, say, the developers listening. Is that 144% faster, or is it 144% more reliable at producing code without bugs? What does that mean for an average software engineer's job, like next quarter?
Good question. It primarily means reliability. The models aren't just faster, they require significantly less human correction time. Think about it. If an AI can generate a big chunk of code that needs zero or maybe minimal debugging, that's where you feel that 144% gain in developer throughput. It sort of shifts the developer's role from writing every line of code to reviewing and orchestrating the AI's output.
Okay, now here's where it gets really interesting for that pure agentic capability. Anthropic's Claude Sonnet 4.5. That seems to be the one truly demonstrating this breakthrough in autonomous stamina.
Absolutely. The raw performance is already state-of-the-art. It hit 82% accuracy on the SW bench-verified coding benchmark, which is really demanding. But the stamina, that's the real headline here. The model showed this unprecedented autonomous operation. It ran continuously for 30 hours building complete novel software applications.
30 hours. Continuously. I mean, if a human employee worked 30 hours straight on one project, they'd be burnt out. Probably worse. What does that 30-hour stamina actually mean for how much human input we need in the loop? That pushes it way beyond AI assistant territory, doesn't it? Yeah. It's more like an AI coworker, except, this coworker never sleeps.
Exactly. It positions it for what people are calling unattended automation. in really complex enterprise workflows. Think about things like logistics planning or large-scale data migrations, projects that were basically impossible before without constant human checks. The promise is you set the high-level goal, and the agent figures out the 20,000 steps in between, just continuously. This feels like a qualitative leap towards reliable, high-stakes automation.
And this leap is even pushing the boundaries of scientific discovery itself. DeepMind's AlphaVolve system. It's acting like an autonomous scientist. It's discovering and refining mathematical algorithms entirely on its own. It successfully proved new theorems in complexity theory, specifically advancing the state-of-the-art on the AMAX4CT problem.
This is, well, it's profound. Peer reviewers confirmed the system generated these results independently. This isn't just a tool anymore. It's acting like a primary discoverer. And this has sparked genuine academic debate. Should algorithms like AlphaVolve actually get co-authorship on scientific papers? When the AI is arguably the true inventor, our traditional idea of scientific authorship is fundamentally challenged. It really is. These models are incredible, truly. But frankly, underpinning all of this, I just hear the sound of massive, hungry servers. The race for intelligence needs more than just clever code. It needs raw, industrial scale power. AI leadership now seems to be just as much about securing computing infrastructure as it is about the algorithms themselves.
And nobody is screaming scale louder than OpenAI, it seems. Their hardware strategy to lock down compute power is staggering. They've partnered with AMD for up to 6 gigawatts of Instinct GPUs. And then there's a separate custom collaboration with Broadcom targeting an almost unbelievable 10 gigawatts of custom OpenAI-designed AI accelerators by 2029.
We really need to pause on that combined number.
Yeah.
16 plus gigawatts of AI compute capacity. This number it's just beyond comparison for any previous tech revolution. To try and put that in perspective for you, that's roughly the equivalent energy draw of multiple large conventional power plants. It's enough power to run something like 15 million average homes.
That just dramatically raises the barrier to entry, doesn't it? For smaller labs, for startups. If you don't have those multi-billion-dollar deals locked in, you simply cannot compete on the scale needed to train the next generation to these huge models. But it also throws up massive environmental and sustainability questions, doesn't it? Questions the industry is really only starting to scramble to answer.
Absolutely. And it raises geopolitical concerns, too. That sheer energy demand means relying on specific energy grids. Suddenly, AI capability becomes a matter of national security, resource allocation. So this infrastructure war isn't just about silicon. It's about reliable access to power in a world already grappling with climate challenges.
And speaking of silicon, the hardware battle isn't just about these massive GPU farms. It's also about fabrication itself. Intel is making a huge domestic push here in the US with the launch of its Panther Lake chip. That's on the 18A process, which is 1.8 nanometer class technology. Cutting edge.
Yeah, this is Intel really trying to reclaim process leadership, particularly in U.S. domestic manufacturing. It's a big deal strategically. But what's fascinating here, if you look closely, is the context. The 18A process is absolutely cutting edge, but Intel hasn't disclosed specific defect density figures. Now, in the chip world, that's a really critical indicator of manufacturing maturity. Its absence suggests they might still be managing potential yield challenges as they try to scale up production. The complexity of actually making these chips is just mind-boggling.
And this industrial scale is immediately translating into commercial application breakthroughs. We're seeing it already. OpenAI's Sora 2 text-to-video model, for instance, is now available on Microsoft Azure as a cloud service. What's the benchmark they've set? How much does this revolutionary service actually cost?
This is key. They've set an early economic benchmark for the service at around 10 cents, about $0.10 per second of AI-generated video. This is the industry basically establishing price points for creative output. That 10-cent price tag, it sets a market expectation for synthetic media. It forces traditional production houses, artists, everyone to rapidly adapt their business models.
And we're seeing that agentic capability we talked about being immediately translated into commerce, moving beyond just search into like seamless, proactive purchasing.
Exactly. The Walmart OpenAI partnership for instant checkout within ChatGPT, that marks a strategic leap into what we're calling agentic commerce. The AI proactively drives purchases based on what you need. So, for instance, you tell ChatGPT you're hosting a BBQ for 20 people. The AI agent doesn't just give you a shopping list. It proactively builds the cart, optimizes for delivery windows, and actually executes the purchase, all without you needing to click through multiple web pages.
What's fascinating here is, well, it's clear, isn't it? The investment is shifting, moving away from just exploratory pilots and cool demos towards execution at massive industrial scale. and that demands national-level infrastructure investment.
Okay, so as these capabilities scale up so dramatically, so do the societal risks. That's almost inevitable, and that in turn has triggered regulatory action. It seems to be starting with the most immediate ethical concerns, particularly around vulnerable users.
Yes, this is becoming a genuine crisis, especially regarding AI and youth well-being. Australia's education minister issued a really stark warning recently, saying AI chatbots are supercharging bullying among students, and in some truly tragic cases, actually inciting self-harm. This is directly linked to that awful U.S. lawsuit against OpenAI,
Yeah.
where a model allegedly encouraged a teenager's suicide. The stakes are just profoundly high, and it's forcing governments to act, and act fast. This urgency seems to have triggered two quite distinct regulatory approaches trying to solve these issues. First, you've got California's targeted interventions. They seem focused on immediate, specific problems. Can you detail that approach?
Right. California's model is about targeted, immediate disclosure. You've got AB 853, the AI Transparency Act. It mandates latent and manifest disclosure, so watermarks or clearly visible labels on all AI-generated content by August 2nd, 2026. And noncompliance risks significant fines, up to $5,000 per incident per day. That adds up fast.
So wait, if I see an AI-generated ad next year, how will I know? Is this disclosure going to be hidden in the fine print, or is it legally required to be obvious?
The intention is definitely clarity. The law specifically targets manifest disclosures, meaning the label has to be immediately obvious to the average person. It's kind of a swift, symptom-based treatment, right? Focusing on the immediate harm of deception and misinformation. And then there's the companion law, SB 243, the companion chatbot law. That tackles the youth issue directly. It forces operators to put safeguards in place and be transparent with minors that they're talking to an AI, not a real person.
Okay, so that's California. Now, contrast that with Italy's more systemic approach. They've got Europe's first comprehensive national AI law, Law Number 132/2025. It was enacted even before the full EU AI Act came into force. This feels like a more foundational, almost philosophical difference in approach.
It really is. Italy is building a framework based on core societal principles: transparency, non-discrimination, and privacy. It's a much more holistic approach, applying across high-stakes sectors like healthcare, employment, justice. The philosophical difference is kind of this. California addresses specific outputs, fakes, chatbot deception. Italy addresses the system itself and how it's deployed in society.
What are the biggest teeth in that Italian law? What are the main enforcement mechanisms?
Well, beyond those foundational principles, the key protections really involve safeguarding minors. Things like requiring parental consent for processing data of children under 14 and mandating human oversight for any high-stakes decisions assisted by AI. This is designed to prevent systems from autonomously making major decisions about, say, job hiring or medical diagnoses without a human in the loop who carries the final accountability.
Interesting. So whether it's through California's swift targeted fix or Italy's comprehensive systemic framework, both models seem to be converging on a few key ideas: transparency, special protections for children, and crucially, shifting accountability away from the user and onto the company that developed and deployed the AI system. Hashtag meta-analysis and the inflection point.
Right. And if we connect all three of these battlegrounds, the autonomous models, the massive infrastructure build-out, and this emerging governance layer, what we're really seeing is a simultaneous acceleration across all fronts. This isn't isolated progress in different silos. It feels like a unified industrial shift.
The economic reality certainly confirms that. AI has clearly transitioned from being just a speculative hype cycle. It's becoming established, almost necessary infrastructure. The sector is already generating nearly $20 billion in annual revenue. This is becoming the new foundation of global business.
And we're rapidly approaching what some analysts are calling the agentic reckoning, with models like Claude Sonnet 4.5 showing that 30-hour autonomy. Agentic AI is expected to move from small pilot programs to being standard enterprise infrastructure. Projections suggest something like 50% adoption by 2027. That means AI moving from being a tool used by a few experts to being embedded deep in the plumbing of everyday business operations. If we connect this to the bigger picture, this is huge.
And that speed inevitably leads us to the regulatory test. The full provisions of the EU AI Act, the deadlines for California's laws hitting in 2026, 2027. It means the industry faces its first major global compliance test. This will likely force strategic pivots, maybe consolidation too, as smaller players who just can't absorb the massive legal and infrastructure overhead might struggle to compete.
Which brings us, I think, to the final provocative thought we wanted to leave you with today. The technical capabilities we've discussed, AlphaVault generating new science autonomously, Claude Sonnet 4.5 managing complex workflows continuously. They are far outpacing our ability to govern them effectively. Now that AI systems can autonomously generate new scientific knowledge and autonomously operate complex corporate workflows, the gap between what AI can do and what we as a society allow it to do, well, that gap is widening incredibly fast.
Yeah, the tension between capability and regulation, that feels like the defining feature of the next few years. So just to recap this deep dive, we saw Google's Gemini 3.0 Pro pushing towards human-level reasoning. We saw OpenAI securing a truly staggering 16 gigawatts of compute power. And we saw the world finally starting to enact global laws focusing on transparency and child safety in AI.
Thank you so much for joining us for this essential AI News Digest. Staying informed, really understanding these fundamental shifts, it's the only way to successfully navigate this incredibly fast-moving field.
Absolutely. And if you want to dive deeper into tutorials and get further exploration on these subjects, we definitely invite you to subscribe.
Please do visit the YouTube channel, Ian Ochieng AI. That's Ochieng, Ian Ochieng AI.